Greetings, we're here with my wonderful friend Quantum Tom to discuss a wide variety of subjects. Never quite know where it's going to go, but the one constant is it always involves liminality. Quantum Tom's kind of an expert in quantum mechanics. He's been studying it for quite a long time, so he knows a little bit about it. So what's new?
New in quantum? Wow. Well, this moment. And now this moment.
But it's one endless moment, really.
As the perception would take us, yes.
Can you find the beginning or end of a moment?
Why would there be one?
So is this the same moment that happened at the beginning of the universe?
Absolutely. Yeah.
I completely agree.
No separation, no time, no space.
Well, Einsteinian physics would disagree with that.
Yes, well, Einstein kind of said that he didn't understand everything.
Yeah, but there's a very wide view that does see time as being a sequential thing, and not all time is happening at the same time.
Yes, I probably on the relativistic level that is an easy explanation. But on the quantum level, that goes away because the time and space dimension don't exist. It is without time. It is without space. It is without dimension. Therefore without description.
And everything is emerging from the quantum.
Exactly. So that time at the beginning, which there was no one of the universe, is the same time that it is now.
Do you believe in the Big Bang?
No. None whatsoever. Doesn't make any sense.
That's fascinating. Yeah, I've never agreed with that.
What was it
either.
that banged?
Well, the larger paradigm does seem to believe that that's what happened. I mean, a lot of physicists have no qualms about saying this is fact, not theory anymore, because they feel they have a lot of evidence.
Well, it gives them something to build off. But if you're building off an erroneous theory to begin with, then you keep building into this no man's land that eventually takes physics, which it has now, theoretically especially, into a realm where there's no possibility of proving any of it. You can't do any experiments that actually relate to string, to multiverse, because we can't leave our universe to find a multiverse. We'll never be able to prove that it's actually real. But they've got these wild-ass theories that actually point to that. But if your starting point, the Big Bang, is an erroneous assumption, then every single theory that flows from it is therefore just as incorrect. But if you start from another premise, saying that there wasn't a beginning, there is no starting point, that it was, that quantum, because it is outside of time and space. There is no linear dimension to it.
Well, you could say it's inside of time and space.
Yes, or it is all of time and space. Therefore, there is no differentiation.
What if time is not an external element, but an internal element?
Yes.
So time is being.
A collapse of probability. So that it actually, we, I think, choose the constraint. Because as we...
Well, we don't choose the form that the bird takes. The bird is a bird.
But the constraint of time. Because to us, I think, because our limited perception, if we try to imagine ourselves in a timeless, spaceless, contextless existence, we wouldn't. You couldn't. You wouldn't be able to grasp that. So you have to somehow bring down the probability so that they collapse into something that for us is manageable.
Do you think that collapse could be, that solidification of matter could be an equivalent of what they're calling the Higgs field, as far as a field that's existing at a frequency above matter that actually allows the atomic to become matter? That there's this, it's like a field that allows for density or for form. Without that field, the quantum couldn't manifest into being.
Yeah.
It would be pure energy.
Yeah. No, the Higgs actually, provides mass to all of the energetic particles that exist, supposedly. And they were desperate to find it. Because if they hadn't supposedly found this miraculous Higgs boson, all of standard physics would have gone away. The standard model relies heavily on there being something that gives everything mass. Without that, there's no reason for mass. There's no reason for gravity. There's no reason for the standard model to exist.
Well, they still don't know what gravity is.
No,
I mean,
exactly.
even with the understanding of the Higgs field, which they don't completely understand, because again, all they've found is a particle of it. But that particle.
They didn't find the particle. They found the reaction to the theoretical particle. They could only trace the map of things that happened after the supposed collision of the Higgs. But they can't see that particle directly, because it's not in our relativistic realm. It's in the quantum realm. They've never seen a muon. They've never seen a Tau. They've never seen a pion. They've never seen a boson. It is only the reaction in the particle accelerators, the collisions.
Pion.
Yeah, whatever. In Britain, it would be pion. It's my British heritage. No, it has nothing to do with it. But again, like you said, gravity, they don't know what it says. So when you start all of your theories based on a conjecture that you cannot prove.
Well, everything in modern physics and all of astrophysics is based off of gravity,
Yeah.
and yet they don't know the contradictions around what
Where'd it
they
come
know
from?
about it. They have no idea.
None
Because
whatsoever.
so, but you couldn't deny its existence with all of
You can't deny its effects. You can't deny there are certain effects, but we don't know if it's attributed to one single thing. These effects could be attributed to multitudes of things, but we're not sophisticated enough. We don't have the equipment to measure all of these particular interactions that go into creating the idea of gravity and the actual showing up of its effects. And it's a placeholder. Gravity is a placeholder, dark matter, dark energy, they're placeholders. The ether, as Einstein would say, because we don't know. And instead of saying we don't know, we just throw them into our theories and build a whole science out of it, which is now completely erroneous because we started out with, we don't know.
Well, yeah, it's tricky because quantum physics has produced such amazing results that as much uncertainty as there still is within it, because of all of our computing and because now we're moving towards quantum computing, they are able to map out the behavior of the dynamics of that realm in ways that 15, 20 years ago it was a frontier, and I mean it's still a frontier 20 years into it.
We're only an inch into 100 miles already. They have no.
But is it a journey that's going somewhere?
Eventually, I hope. But again, because of the timeless, faceless dimension, it's actually going to end up nowhere, and that's going to be the good part. Because when we find out that there is no here, it'll open us. It'll expand our availability to the realms of possibility. It won't shrink them like we do now, because science tries to constrain things. All of the theories try to put things into a box, a neat little mathematical formula. They don't try to expand our understanding, they try to constrain it. They always want to have this so they can write it down, they can hand it off, they can say whatever it is, whereas an expansion, an unlimited, where you remove the barriers of the theories and actually delve into different realms. We're not quite there yet, because quantum computing is still, as they always say,
well, it's
10 years in the future, but it's not. It's many years. We're so far from it. One, we don't understand the quantum realm. We don't understand the particles that actually come into existence.
Do you think we're close to understanding the quantum realm?
No, and I think that's a good thing. I do. Yeah, no, because it's dangerous as shit. If we figure that out now, as who we are as human beings, forget it, we're toast. Not that we're not already, but...
But maybe our figuring it out will help us spark an evolution of some sort.
Yeah, no, I think the process of trying to figure it out is going to spark many different evolutions, because it's going to be a long process, because it's a very intricate, I mean, there's so many intangibles that we're not even aware we need to include at this point. We're not even aware of their existence because we haven't, the quantum model, I can't even remember what the heck they call it, it's like the standard model, but it's on the quantum realm. And it's the one that has the chart with the muon, the pion, and all the other things. They're still trying to fill in, that's where the Higgs, they tried to fill that in. There was a gap in that model as well. But again, the Higgs doesn't stop. It doesn't put an end to anything. Because now all of a sudden they're coming up with different Higgs to try to explain things that aren't explained by the original Higgs, which they never saw to begin with, only the results of. So again, we start from a premise of not actually having a finite idea, and you're going off in infinite directions without ever having a starting point, which is how we got here to begin with anyway.
Yes.
Infinite directions without a starting point.
And then we wind up right where we began.
Right where we began. It's all a circle. All a circle.
Well, I look forward to more discussions with you, brother.
Absolutely, Robert.
Okay, cool. Thanks for watching. Be sure to like us and subscribe. Hit the bell icon to be notified for when we post new videos. We really would encourage you to ask any questions that you have. We would love to answer them and address them in any way possible. And we will talk to you soon. And remember, stay focused on the question.